Sorry. Okay, boys and girls, we're going to try right now to do some Lewis structures. I'm going to show you, I'm going to walk you through how to do it. I'm going to start with hydrogen. That was the first one on your worksheet. All right, hydrogen H2. Okay, so the first thing I want to do is I'm going to draw the two atoms on paper. Okay, there's only two, so they can only be next to each other. There's no issue of which atom goes in the center. Now, also I want to state that hydrogen is never an atom that can go in the center. And the reason is hydrogen can make one bond and one bond only. Once it's made one bond, it has maxed out the valence electrons that it can take. All right, so now we need to start our accounting for valence electrons. Okay, so I have two hydrogens. They each have one valence electron. So I have two valence electrons that need to be accounted for. All right, I've got my two hydrogens next to each other. I can't have a molecule without a bond, so I'm going to make one bond. One line represents two electrons being shared by two atoms. So I'm going to subtract this from my total. I've got 0 electrons left. So every electron has a home, and that's one of our steps we need to check on. And now we need to go back and check our octet and our duet rule. Octet means a set of 8, and most atoms have a stable octet. Hydrogen, however, is one of our small atoms, and so hydrogen is happy with only one electron. We can say that it can claim both of these electrons, and when it does, that fills the 1s orbital. So hydrogen is as happy as helium here because it's got its 1s orbital filled. So it's happy, it fills the duet rule, and we can check that off. All right, let's look at fluorine. That's the next one on your list. Okay, fluorine, obviously we're going to have two fluorine atoms. We're going to do our accounting. I have two of them. Each one, these are in group 7A, so they have 7 valence electrons. 2 times 7 is 14. All right, I can't have a molecule without a bond, so I'm going to give it one bond. All right, that line, that one bond, uses up 2 of my 14 electrons, leaving me with 12 electrons that need homes. All right, so now I need to go back and I need to check my octet and duet rule. Obviously, these don't fulfill the duet rule. These are, like most atoms, they take 8 valence electrons to be stable. All right, so in its current state, they only have 2 electrons. The thing about the bond is that everyone attached by that bond gets to claim both electrons in the bond, and that's how we get to achieve this stable octet. All right, so right now this fluorine has 2 valence electrons and this fluorine has 2 valence electrons, but they want to have 8 valence electrons. So I'm going to take my leftovers, and the rule is I'm going to distribute them from the outside working in. All right, and there is no inside here. Again, we don't have a central atom. So I'm going to start here, and I'm going to give this one 1, 2, 3, 4, 5, 6, 3 lone pairs. All right, I'm going to come over here, 8, 10, 12. I've used up all of my valence electrons, so I can check that I have nothing left. And then I'm going to recheck my octet rule. This fluorine has 2, 4, 6, 8 electrons, and this fluorine has 2, 4, 6, 8 electrons. Everybody's happy, so that's my final structure. All right, I want to move on to HCl. HCl is the next one on your worksheet. HCl, of course, we have an H and we have a Cl. Again, we only have 2 atoms. All right, our hydrogen, we have one of them with 1 valence electron. Chlorine, we have one of them with 7 valence electrons. So we have a total of 8 valence electrons. All right, I'm gonna make one bond because you can't have a molecule if you don't have a bond. 8 minus the 2 in the bond gives me 6. All right, I have 6 electrons left over that need homes. Hydrogen is full, it can't take any. But chlorine here has only 2, it wants to have 8. So I'm going to give it 2, 4, 6. I have no electrons left, and now it satisfies the octet rule, and so does hydrogen. All right, next one on your list was water, H2O. Okay, here's the first case in which we have 3 different atoms, 3 atoms, not necessarily different atoms. The rule is that the atom with the highest electronegativity always goes in the center. Additionally, though, hydrogen can never go in the center. So hydrogen cannot be a central atom. So that leaves us with only oxygen as a central atom. And I can put those in a number of different configurations. I'm going to write them like this right now. Oxygen is now my central atom. It's the only one that can be in the center. All right, let's do our counting for valence electrons. I have 1 oxygen. It has 6 valence electrons. I have 2 hydrogens. They each bring 1 valence electron. Altogether, I have 8 valence electrons that need homes. Okay? Now, I have to make bonds. Everything gets 1 bond into my central atom, and that used up 4 valence electrons, 2 here and 2 here, leaving me with 4 left. All right, now the rules say I start from the outside and work my way in, distributing valence electrons where needed. My hydrogens, however, are completely filled with just their 2. So the only one that needs electrons is oxygen. You can see oxygen has 2, 4. It has 4 valence electrons, so it needs 4 more. So I'm going to go ahead and give it 2 here and 2 here. And there we go. Everyone fulfills the octet and duet rule, and that is water.